the demo. The source code is available in the Cylon GitHub repository on the CPP source tutorial. I have checked it out into this node which is running Jupyter Lab. So let's get to CPP source tutorial. Let's look at the README file that gives the instructions on how to run the demo. This demonstration takes in some CSV data from an application called Killer Bee, and these data have been taken from an article titled Merge and Join Data Frames with Pandas in Python by Shane Lem. So let's first look at the CPP code. This is a typical Cylon CPP application, and you start off by creating a Cylon context. I'm creating a Cylon context using an MPI configuration. So a Cylon context would give information about the rank, about the world size, as well as some cluster-wide operations like barrier, etc. And a typical Cylon operation would take in a shared pointer to a Cylon table and then would return a Cylon status that would indicate whether that operation was successful or not. So here we would each worker would read its corresponding file from the data directory, and it would load the data first and then perform a distributor join operation. It will be an inner join operation on indices 0 and 3 on this CSV1 and CSV2. And we would look at the number of rows in each of these tables as well as in the output join table. To run this example is included in the main CMake file of Cylon, so you can simply build the project that will build all the libraries required for the example by simply passing CPP and release to the build.sh script. I have already built it in this in this particular node, so I would run the demo join here. This is the single threaded operation, and as you could see here, the first table has 272 lines, and the second has 240, and the joint has about 159 lines. For distributed operation, I'm using MPI, so I would use MPI run minus np, and I'll pick 4 processes, and the executable would be the same. So we would have the same executable, but in this particular node I have InfiniBand available, so I would need to pass some more arguments. So I'll pass these. So let's run this and see. So as you can see here, there would be 4 processes, and each of the processes would be reading the corresponding CSV file from the data directory and then performs a distributor join. And at the end of the distributor join, the join shards are available in the corresponding processes. And the identical example to the CPP is also available in Python. It's the same. The only difference would be how you execute it. When in the Python environment, you would first have to create a virtual Python environment, and then you would have to pass the environment directory to the build.sh script with --python flag, and you would also have to set the LD library path with these arrow libraries and the Cylon libraries. Execution would be the same. It would be identical to the CPP.